Welcome everybody. Today we are looking at exponents and radicals, lesson 4. It's part 2 of the entire radicals and mixed radicals section of the notes. So last section in lesson 3, we were looking at converting entire radicals into mixed radicals. But today we are going to look at going the other way. So let's get started. They've got a nice description here of how to do that. I'm not a big fan of the wordy descriptions. I like to see an example, so I think we'll jump right into the example. I think it'll help a little bit more. So here our example is 3 root 14, or 3 multiplied by square root of 14. And we want to convert that into an entire radical. So the trick with this is trying to convert that 3 into an expression. Maybe I should use green. There we go. Convert that 3 into an expression that has a square root. So we know that the square root of 9 is equal to 3. And if you want to think about it the other way, you can say, well, it's a square root, so I need to convert that 3 into a square root. So I can square 3, which is my value, to get 9. And that'll tell you that you can convert that 3 into a root 9 because they mean the same thing, right? They're actually equal. So you convert that 3 into square root 9, or you change it, and now you have square root 9 multiplied by square root 14, and you can convert that to the square root of 9 multiplied by 14 altogether. Or if you actually multiply 9 by 14, you get the square root of 126. So when you are converting it into an entire radical, just remember the whole expression has to be under the radical sign or the root sign. So anything you have on the outside, you want to convert into the form of a square root or a cube root or whatever you're dealing with. So let's try a few example questions. Convert the following mixed radicals to entire radicals. So here we have 2 root 5. So normally with my videos, just before we get going, if you want to try these on your own, I would highly suggest it. You can push pause on the video and you can try them all and then push play and I'll go over them and you can check that you've got the right answer. That's usually a really good way to do this. If you're tired or you have no idea what's going on yet, just keep watching and take notes and hopefully it starts to click for you. So here we have 2 root 5 and we want to convert that into an entire radical. So that means the whole expression is going to be under the square root sign. So I need to deal with this too. It's outside of the square root sign, but I can convert that into root 4 because the square root of 4 is 2. So now I have root 4 multiplied by root 5, and I know that I can convert that into the square root of 20 because root 4 times root 5 can be written as the square root of 4 times 5. And now we have 4 root 7. So I need to convert this 4 into an expression under a square root sign. And we know that 4 squared is, there we go, technology. 4 squared is 16. So I can say that 4 can be written as root 16. Now I have root 7. And that whole thing can be written as root of 16 times 7. And 16 times 7 is 112. And that's it, you're done. The last one, 10 root 6 can be written as, well, we're trying to deal with that 10. We want it as an entire radical. So we want the whole expression to be under the square root sign. So 10 can be written as the square root of 100. Hopefully my square root signs get better. I keep missing the little tail there. Multiplied by the square root of 6. And then we can combine that to be the square root of 100 times 6, or the square root of 600. So it's basically just going the opposite way than we did yesterday. There's a few key things to remember here. So if you are doing this and the number out in front of the square root is a fraction, what you want to do is deal with them each one at a time. So you can say, well, if we're dealing with the 3, we know that's can be written as the square root of 9. And then now we're dealing with the 2, that can be written as the square root of 4, all multiplied by the square root of 8. And we know from lesson 2 or lesson 3 that the square root of 9 over the square root of 4 can be written as the square root of 9 over 4 multiplied by the square root of 8. And then we can combine both of those. So we get the square root of 9 over 4 multiplied by 8. And if you type that into your calculator, you can combine those two. There's another cool way to think about it here, because basically what you've got is 9 over 4 multiplied by 8, but you can extend that and say that is 9 times 8 over 4. And if you want to do really quick math, you realize here that 8 over 4 can be reduced, right? We know that 8 divided by 4, here we go. 8 divided by 4 is equal to 2. So now we have 9 times 2 is equal to 18. So it seems like a bit more of a process, but as soon as you get used to doing that, you can see, 8 over 4, that's just going to be 2. 9 times 2 is 18, so that is equal to the square root of 18. Maybe I should put that underneath so it's not in the way. Square root of 18. The next one, so that's how you deal with fractions, right? You can just do the top and the bottom and then combine everything. The next one is decimals. So if you have a decimal and you want to turn it into a term or an expression with the square root above it. So let's just kind of visit. We know that the square root of 16 is equal to 4. So whenever you take the square root of a number, it gets lower, right? The square root of 9 is 3, so 3 is smaller than 9. And this works for everything from 1 and greater than 1, basically. 1 and greater. If you have anything between 0 and 1, like this decimal, 0.4, the value actually gets smaller. Or it gets larger, sorry. Totally got myself mixed up there. So here we're going smaller. But now if we're taking the square root of a decimal, it's going to get larger. And so I'll show you what I mean. If we take 0.4 and we square it, we're going to get 0.16. So if we take the square root of that 0.16, we're going to get 0.4. And you can see that when we're taking the square root of 0.16, our value is getting larger. Hopefully that makes sense. So what I would do if you had something like 0.4 is I would type in my calculator 0.4 squared, and I would get, look, it's 0.16. So that means I can rewrite this as root of 0.16 multiplied by root of 50. And all of that is equal to the square root of 0.16 multiplied by 50. And if you type that into your calculator, 0.16 multiplied by 50, then you are going to get the square root of 8. I guess we should put our answers in squares. That's a good habit to be in. And then the last one is when we have a negative sign, we know that we can't take the square root of a negative number, but what you can do is deal with that separately. So it'll be negative the square root of 25, because 5 squared is 25. So if I can write that nicer. Negative root 25 multiplied by root 7, which is the same as negative root of 25 multiplied by 7, or negative root 175. There you go. That's it, converting mixed radicals into entire radicals. There are some trickier problems we can do with an index of 3 or greater. So we're looking at cube roots or fourth roots or fifth roots, and they do get a little bit tricky, and it's good to have some of the square roots and cube roots memorized, but in this case you can just cube things if you're unsure. So here's an example. We have 1/2 multiplied by the cube root of 80, and we want to write this as an entire radical, so the whole expression needs to be under the cube root sign. So we can say, well, if we take 1/2 and we cube both top and bottom, you get 1/8. 1 cubed is 1, 2 cubed is 8. So you can say that this is the cube root of, hang on, let's scroll up. I think if I touch the bottom of my screen, things get wonky. The cube root of 1/8. And then if you have the cube root of 1/8 multiplied by the cube root of 80, oh man, you can say that it is the cube root of 1/8 multiplied by 80. And when you multiply 1/8 by 80, you get 10. So 1/2 times the cube root of 80 is the same as cube root of 10. So here we have 2 multiplied by the fourth root of 3. So if you say 2 to the power of 4, you will get 16. So that is the fourth root of 16 multiplied by the fourth root of 3, which is the same as the fourth root of 16 times 3, or to simplify even further, the fourth root of, bottom of the screen again, the fourth root of 48. Okay, now we have -4 multiplied by the cube root of 7. So I can say 4 cubed, and that will be 64. So then I can convert that -4 into negative cube root. Oh, wait. Oh, no, that works. Negative cube root of 64. And that's multiplied by 7. And then we can say negative. Hopefully that stops doing that. I got it on pen. What is going on here? Negative cube root of 64 times 7 is 448. The other way you can do that one, and this is why I said, oh wait, before, because you're actually allowed to have the negative cube root, right? You're allowed to have a cube root of a negative number. So this term right here could have also been written as the cube root of -64, and that would have given us the answer of cube root of -448. They're the same thing. It's the same answer, but I just wanted to show you that you could answer it either way. And then I'll do D here. We'll leave C maybe for in class. So you have the fourth root, or -3 multiplied by the fourth root of 2. So you can say 3 to the power of 4 is 81. So now we have negative fourth root of 81. We converted that 3 into the fourth root of 81 multiplied by the fourth root of 2. And then you can say negative fourth root of 81 times 2, or to simplify even further, the negative fourth root of 162. Awesome. That's it for this lesson, converting mixed radicals into entire radicals. It might seem pretty straightforward, but you definitely should practice so that you can feel super confident with this. And if it doesn't seem straightforward, we're gonna have lots of time in class to work on it. So thanks for watching, and have a good day.